Now we will study law of multiple proportion. This law was given by Dalton in the year 1803. This law also deals with the mass ratio of a compound as law of definite proportion. It states that the law of multiple proportion states that if two elements combine to form two or more compounds, the mass of one of the elements which combines with the fixed mass of the other in these compounds bear a simple whole number ratio by mass. First of all, we will understand the term simple whole number ratio, and then let us take an example to understand the above statement of the law of multiple proportions. Simple whole number ratio is generally considered as the ratio of whole numbers from 1 to 9. Example of simple whole number ratio is 2:5, but 9:11, not a simple whole number ratio. That means a ratio of 1:9, 2:5, 3:7, 4:7, all are simple whole number ratio. And 7:15, 9:11 are not at all a simple whole number ratio. Now, example. In this example, hydrogen combines with oxygen to form two compounds, namely water, that is H2O, and hydrogen peroxide, that is H2O2. In water, the reaction is 2H2 plus O2 equal to 2H2O. Here the ratio of hydrogen and oxygen is equal to 1:8. In hydrogen peroxide, the reaction is H2 plus O2 equal to H2O2. The ratio of hydrogen and oxygen in hydrogen peroxide is 1:16. That means with the mass of 1 unit of hydrogen, oxygen attached in H2O is 8 unit and that of H2O2 is 16 unit. So the ratio will be equal to 1:2, which is a simple whole number ratio. So this example proves the law of multiple proportion. We can take other examples. In this example, carbon combines with hydrogen to form methane CH4, ethane C2H6, ethylene C2H4, and acetylene C2H2. In methane, the ratio of carbon and hydrogen is 12:4. Similarly, in ethane, the ratio is 12:3. In ethylene, it is 12:2, and in acetylene, it is 12:1. Now, with carbon 12, hydrogen attached in the ratio 4:3:2:1, which is a simple whole number ratio. So this example also satisfies the law of multiple proportions. The other examples are now in compounds of nitrogen and oxygen. Nitrogen and oxygen combines to form 5 oxides. These are nitrous oxide, that is N2O, nitric oxide, that is NO, nitrogen trioxide, N2O3, nitrogen tetroxide, N2O4, and nitrogen pentoxide, N2O5. The ratio between the weights of oxygen in all the above listed oxides, which combines with 14 parts by mass of nitrogen, is 1:2:3:4:5. That is in simple whole number ratio. Since the ratio comes out to be simple whole number, therefore the law of multiple proportions is supported. Similarly, carbon forms two oxides, carbon monoxide and carbon dioxide, CO and CO2. Here also the law of multiple proportion is supported. Similarly, sulfur and oxygen constitute SO2 and SO3, that is sulfur dioxide and sulfur trioxide. It also supports the law of multiple proportion. These are the examples basically of law of multiple proportion. Now we will study the limitations of this law. Now carbon combines with hydrogen to form simple alkanes, namely methane CH4, ethane C2H6, propane C3H8, and butane C4H10. The ratios are given in the sheet. The ratio of hydrogen in all the four simple hydrocarbons by mass with 12 unit of mass of carbon are 4:2.67:2.5, which is not a simple whole number ratio. Therefore, the law is not applicable here. Similarly, the law is not applicable for isotopes and also for impure compounds. That is, the chemical compound must be pure. Law of reciprocal proportions. The law was given by Richter in 1792. The statement of the law is the ratio in which two elements combine separately with a fixed mass of the third element is either the same or is a simple whole number multiple of the ratio in which these elements combine with each other. Let us illustrate the law with an example. Consider three elements, namely carbon, hydrogen, and oxygen. Let both hydrogen and oxygen combine separately with carbon to form methane, that is CH4, and CO2 or carbon dioxide respectively. At the same time, let hydrogen and oxygen also combine with each other to form water, that is H2O. In methane, The ratio of carbon and hydrogen is 12:4. In carbon dioxide, the ratio of carbon and oxygen is 12:32. Thus, the ratio of hydrogen and oxygen combining with a fixed mass of carbon in the two compounds is 4:32 or 1:8. Now, hydrogen and oxygen combines to form water. In water, hydrogen and oxygen have combined in the ratio 2:16 or 1:8. Since the two ratios are same, therefore the example illustrates the law of reciprocal proportions. Similarly, we can take another example. Hydrogen combines with sulfur to form hydrogen sulfide. Hydrogen and sulfur is in the ratio of 2:32. Similarly, hydrogen and oxygen combines to form H2O in the ratio 2:16. So, with 2 units of mass of hydrogen, sulfur and oxygen combine with a ratio 32:16 or 2:1. Now, sulfur and oxygen also combines to form sulfur dioxide. Here in sulfur dioxide, the ratio of sulfur and oxygen is 1:1, which is a simple multiple of 2:1. Similarly, sulfur and oxygen also combine to form sulfur trioxide. In sulfur trioxide, the ratio of sulfur and oxygen is 2:3, which is also a simple multiple of 2:1. Now, the limitations. This law is not applicable for different isotopes of the same element, and this law is also not applicable for impure compounds. Gay-Lussac's law of combining volume. This law is only concerned with volume ratio of reactant as well as product if they are gases. On the contrary, all other laws of chemical combination are concerned with the mass ratio. It may be noted that the volume of gases involved in a particular reaction must be expressed in the same units. Now the statement of this law. Under similar conditions of temperature and pressure, whenever gases combine, they do so in volumes which bear simple whole number ratio with each other and also with the gaseous products. Let us take an example. The reaction is carried out according to the following equation. 2H2 plus O2 equal to 2H2O. The volume ratio of hydrogen, oxygen and water vapor is 2:1:2, which is a simple whole number ratio. Similarly, we can take another example of ammonia formation. N2 plus 3H2 equal to 2NH3. The volume ratio of reactant is 1:3. That is N2:H2 equal to 1:3. If we take products with the reactant, then we will get N2 is to H2 is to NH3 equal to 1 is to 3 is to 2. This is also a simple whole number ratio of volume. Limitations of this law. This law is only applicable for gases because the volume of solid or liquid is very small as compared to gases. If you want to get more videos, please like and subscribe to this channel and press the bell icon.